Hello everyone. Today we are going to do few sample problems for combinatorics. These problems coming from SOA sample problem list, and we are planning to do few problems just to get to see what kind of problems they would ask in the exam P. Take a moment and read the problem. So in this question, it says there are 80 modems in inventory, 30 coming from source A. So we have source A. There are 30. And then we have the source B, the rest. So basically 50 coming from source B. Then the total is 80. Then you can see that of the modem in inventory from source A, 20% are defective. So if I want to divide this 80 to defective and non-defective, you can see that how many are going to be defective. So 20% from A is defective. So you multiply 30 by 20%. That would give you 6. And then from source B, 8% are defective. So 50 by 8%. That give you 4. So total 10 defective. Okay, so if I want to divide this 80 to defective, non-defective, 10 are defective and 70 are non-defective. So now the question asks a probability that exactly 2 out of sample of 5 selected without replacement from the store inventory are defective. So what's the probability? The question also about probability. Okay. So remember that there are no order for this one. I mean, we cannot distinguish between defective items. They are all like defective. Okay, so how many ways we can choose 5 items from this 80, because we need to choose 5 modems. Okay. So how many ways we can choose 5 items? 80, choose 5. Okay. Then we need 2 to be defective. So there are 10 total. We need to pick. So our sample is 5. Then 2 need to be defective. Then 3 need to be non-defective. So this is defective, and then this is non-defective. Okay. So we have total 10 defective items. So from 10, in that particular sample, we need to have 2 defective items. Then the rest need to come from non-defective items. We need 3 because our sample size is 5. Okay. So when you add these 2 and 3, it should be 5. Okay. So this is the probability. So here you pick, this is the number of ways you can choose 2 defective items from 10 defective items. And this is how you choose 3 out of 70 non-defective items. And this is a number of, as a group, how you can choose 5 items from 80 modems. Okay. So when you solve this one, you should get the answer. I'm not going to simplify this. You can do this. The answer should be 0.102. So here you can see another problem. This is sample problem 97. This one says 30 items are arranged in 6 by 5 arrays as this. And we want to calculate the number of ways to form a set of 3 distinct items such that no 2 are in same row or same column. So a number of ways to form a set of 3 distinct items. So however, the way you choose the 3 distinct items, that doesn't matter. So we are really into a groups, or you can say combination problem. Okay. So it's not like a permutation problem. That's something you need to really understand. Okay. So it's not a permutation. So let's go with, so we are going to pick 3. Okay. So the first item. How many ways I can choose this? how many placeholders are there. So you can see that in this side, I have what, 1, 2, 3, 4, 5. And this side I have 6 columns. I mean the 6 rows, 5 columns. So total I have 30. So the first item, there are 30 possible ways. Okay, so 30 ways. Okay. So let's say you use this one. Okay, so this. So then once you choose that, how many remaining cells are there for you to choose? Of course, it should be one of these columns, one of these rows. So you left with those columns and those rows. So you can see that if I count this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I had to leave those and then choose the other other cells. Okay, so in order to have, remember that it should be no two are in same row or same column. Okay, so they cannot be in same row, same column. So how many are there? Then I have only actually 20 left. Okay, for the second item, there are 20 ways. Okay. So now if I remove so the next one, then you can see how many left for me to choose. You can see that now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12. So for the third item, 12 ways. Okay. So this one give us permutation because we are really considering about the way we choose. So number of permutations is going to be 30 times 20 times 12. The number of combinations. Remember, it's a 3 item, so we can divide by 3 factorial to get the combinations. Okay. For example, remember that permutation count A, B, C and C, B, A are 2 different items. So if I want to get the combination, I have to divide by 3 factorial to get the number of combinations. Remember the formula in NPR. What is this? This is n factorial and n minus r factorial. Okay. Then the NCR, how you get NCR? That's basically you divide NPR by r factorial. That's how you get NCR. So the combination is basically you divide permutation by the size of the group factorial. Yeah, so R is the size of group and we take the R factorial. So that's the answer. So when you do this, you should get the 1200 as answer. So next one, take a second and read the problem. So here you can see that there are 27 pieces of luggages. Airline luggage handler damage random sample of 4. So then the probability that exactly one of damaged piece of luggage is insured is twice. The probability that none of the damaged piece are insured. Then we want to calculate the probability that exactly 2 of the 4 damaged pieces are insured. So the information is about like exactly one of the damaged pieces of luggage is insured is twice. Then the question is about exactly 2. So we had to use the information to calculate, find something and then use that for the next second part. Okay. So so there are 27 pieces of luggages. Then some are going to be damaged, some are not going to be not damaged. So let's say a number of damaged pieces. Some are going to be insured, some are going to be insured. So let's say R is insured. So number of R luggages are insured. Then how many are not insured? We have 27 minus R. Not insured. So then let's see the probability. Okay. So we need exactly one of them to be damaged when you pick a sample of 4. So sample size is 4. From 4, we need one to be insured. I mean, one to be damaged and insured. Okay. And 3 to be not insured, insured and damaged. Not insured and damage. Okay. So how many ways we can do this? So there are insured item. Then we have to choose one. Okay, in to be in that sample. Okay. This is the damage sample. Okay. Then how many left? Not insured. 27 minus R. Then we have to pick 3. And those 3 are actual damage, but they are not insured. Okay. Then how many ways you can choose 4 items? 27, choose 4. Okay. Now this is same as twice. Okay. The probability that none of the damaged pieces are insured. Okay, so none of them damaged pieces are insured. So you don't want any insured one to be in this set. So R0, R choose 0. And then all the damaged pieces need to come from the not insured one. And how many ways you can choose this? 27, choose 4. Why there's 2? Because it says twice the probability. Okay, so this side you have the exactly one of damaged piece is insured, and this side you have none of damaged pieces is insured. Damaged luggage is insured. So not insured. So when you solve this, you should get R to be equal. So you can solve this equation, and you should get R equal 8. Okay, you know how to solve this. Once you get that, then we go to the second part. Now it's asking exactly 2 of the 4 damaged pieces are insured. So now we know the R. R is 8. Okay, by solving this equation. This equation, let's say it's 1. Solving this equation 1. So then there are 8 insured, and then how many not insured one? There are 19. Okay, so 19 without insurance and 8 with insurance. So now we want to calculate the probability that exactly 2 of 4 damaged pieces are insured. So from 8, we need 2 to be in our damaged sample. From 19, which are not insured, we need another 2 to be in our sample. And then total, we have 27, and we can pick any 4. Okay, so these are the, this is the probability. And you can solve this, and you should get the 0.27 as your answer. Let's go next one. Take a moment and read the problem. The question says an insurance agent meets 12 potential customers independently, each of whom is equal likely to purchase an insurance product. 6 are into auto insurance. 4 are like to buy home insurance. 2 are interested only in life insurance. So I can write auto, 6, homeowner, 4, and then life, 2. Okay. And the agent makes 6 sales. So the sample size is 6. Okay. Then calculate the probability that, and actually he meet 12. Okay, so that's another thing. When you add all of this, you get 12 here. Calculate the probability that two are for auto insurance, 2 are for homeowner, and 2 are for life insurance. So we are calculating probability. So how many ways we can choose? We can sell these 6. This 12 choose 6. Okay. We don't consider the order. It's just a group. As a group, we sell 6 insurance. Then we need to sell two auto insurance. So there are 6 people interested about auto insurance. Then we need to sell to 2. We don't care about whom we are selling. Then from 4 homeowner insurance who like to buy, then we need to sell other 2. Then for the life, remaining 2, we need to sell both of them need to buy the life insurance. So this would be the probability. So here you have the number of ways you can sell. Then here number of ways you can sell the, number of combinations. You can sell the auto insurance to 2 people. Same for the home. Same for the life. So you get the answer when you solve this one. So I leave for you to do the solving, that one, and you should get the 1097 as answer. So this is the last one we are going to do. Take a moment and read the problem. So this one says in a group of 25 factory workers, 20 are low risk, 5 are high risk. Okay, so there are low risk, 20, and high risk, there are 5. So total 25. And add this. Then 2 of 25 factory workers are randomly selected without replacement. So you pick 2 without replacement. Calculate the probability that exactly 1 of 2 selected factory workers is low risk. So first, how many ways you can pick 2? There are total 25. You can pick 2. We don't care the order we pick. It's just as a group, 25 choose 2. Then in that 2, we need 1 to be low risk. Then the remaining 1 need to be in the high risk. Okay. 20 choose 1 because there are 20 low risk people and low risk workers. And we choose 1, and then the rest coming from the high risk. And the rest is actually only 1 more worker because sample size is 2. So this would be the way you get the probability. When you solve this, I leave you to do that. You should get this 0.333 as solution. Okay, that's all. We meet again in module 3. Thank you.